Okay, was cut off just now. Never mind, we will continue. Okay, so if you don't know the answer straight away, you can let this be equal to whatever alphabet you want. So I let it be X. Okay, so these two, remember, this is the base. 16 to the power, this is the index. 16 to the power X equals to 2. Or 2 equals 16 to the power X. Okay, and if you remember from your indices, this is how you do it, right? And 2 means 2 to the power 1, right? Okay, so it means this. Like that. So this 1/4 lah. That means what it means is that 16 to the power of 1/4, answer is 2 lor. That's all. Okay. This one, if you can't see what the answer is, you again let this log of base log of 2 to base 16 be equals to x. So 2 is equals to 1 over 16 to the power of x. Okay, change this denominator to base 2. Okay, and then you have to make this become both base 2, and then your answer will be x equals minus 1/4, like that. That means 1 over 16 to the power of minus 1/4, you press your calculator, your answer should be a 2. That's all. Okay, I think we have enough practice on this already, right? I think you should be quite clear. Okay, now I'm going to move on to something else. What we call, we go deeper into it. Now I ask you, 2 to the power of what? You know, right? This is the base. Now you should know already. This is the base. All these are the base. The number at the bottom, it makes sense, right? It's the base. Okay? So this so-called answer of this log is the index. So 2 to the power of what is equal to 0? You ask yourself. You can pause the video. Anytime you can pause the video. So the answer is nothing, right? I'm not saying nothing. It's not defined. No such thing. So we cannot have the argument 0. Cannot. So logarithms has its own rules. The argument of log cannot be 0. Okay? Now let's try another one. Okay, so this one is to prove to you cannot have. Cannot have 0 as the argument. Now let's, how about minus 1? 2 to the power of what is minus 1? You think about it, I can pause the video. Let's say you pause already. Again, cannot make it, right? Cannot make it. So your argument cannot be 0. Your argument cannot be minus 1. Okay? Actually, all this is common sense one. It's common sense. You know what I mean? So when you study, it must make sense to you. It's not like, wow, the teacher say this, that I must memorize. No. It's not that, If you understand why cannot, right? You see, does it make sense to you that cannot? No number, you raise base 2, no number that you raise it to will give you 0. Don't have. Okay? And no number for base 2, you raise it to any number, right? It won't give you a negative number, you never, right? Okay, how about 1? You think about it and you pause. Base 1 means 1 to the power of what equals to 1? Oh, this one, you think about it first. Okay, let's say you pause and then you thought about it already. It can be many answers, It can be 1, it can be 2, can be 3, can be 4, can be 1 million, can be whatever. Infinity. Okay, because 1 to the power of any number. In fact, 1 to the power of 0 also. Okay, any number is 1, right? So it's also not defined. Alright, so you have to understand that certain things you cannot have base 1 as you cannot have base 1 okay, cannot have base 1. You cannot have a negative here for logarithm. It's common sense. Cannot have 0 as the argument for logarithm also. You cannot get the answer. Okay, now let's look at the next thing. How about this? 4 to the power of what is 4? Answer is 1. Then 100 to the power of what is 100? 1 no. So there's something that I want to show you lah. For this one, what I want to show you is, okay, later, if you want, you can take a snapshot of this lah. Okay, these are all the rules that I want to show you. Okay, so we have gone through this already. Index form is like that. Alright, you must be able to change from index form to logarithmic form. Okay, so I told you already, this is the base, this is the index, and okay, this is your answer, right? So log of y to base a is equals to the answer, which is the index. Okay, you must be able to change from here to here, here to here, interchangeably. You must know how to do that. Okay, and we discussed just now, right? Your y cannot be negative. Because your a, right, is defined as positive. You know, when you learn all your indices laws, your a is positive. Do you remember? So your a is positive, and if a is positive, the y, the answer can never be negative. Okay, and we also discussed just now in this. Just now that you can go back to the video lah. We say that the base cannot be 1, right? So this is the definition lah. Okay, so you must know this because you know why you need to know this, because later we will learn the log graph also. Okay, now special logarithmic values. This is what I want to show you. Log of a to base a, right? Okay, that means if you see this answer same as this base, this definitely has to be a 1. Okay, so that's what I wanted to show you. It's here. Is it here? Yeah, it's here. Okay. Yeah. There. So I was trying to tell you, right? Cannot be defined. Okay, so this was what I was trying to tell you here. Okay. Okay, okay, now how about this? Log of 1 to base 7, what is it equal to? Okay, the answer, whenever you have log of 1, right, to any base, okay, it can be log of 1 to base 10, log of 1 to base 12 or whatever the answer is always equal to 0, because anything to the power of 0, anything to the power of 0, anything to the power of 0 is 1. Okay? So I hope you are clear on that. Okay, sorry here. So another special logarithmic value that you must know is log of 1 to any base is 0. Okay? Now must you like go memorize. Actually, no need. It's common sense, right? A to the power of what is 1? 1, no? Okay? A to the power of what is 1? 0, no? Okay? So there's no need to study until so poor thing. Okay? You just use common sense, okay? All of us have common sense, so you just use your common sense. Then when you do your work, right, you activate the common sense in you. Okay? Okay, now I skip this for now. I'm going to elaborate more on this. Okay, now let's say just now we were asked to evaluate, right? All these are evaluate, right? Evaluate means find the value, the answer, which is in index. The answer is actually the index. Okay, now let's say I ask you to solve. Solve definitely involves an equation. Okay, and the way to solve is very simple. You need to change from index to logarithmic or logarithmic to index form. Okay, you have to use this skill that you learned. So this is your base, this is your index, this is your answer, right? So x to the power of 2, which is x squared must be equal to 25. Then you can get x to be equals to 5. Why like that? Something wrong, right? By right, it should be, if you were to square both sides, or square root both sides, sorry, you should get 5 or minus 5, right? Okay? So actually this way is not really the correct way lah. You should show that there are two possible answers, but can you accept both answers? The answer is cannot lah, because you see, whenever you solve an equation, okay, you must go back to the original equation and see whether your answer fit into the equation or not. So you see, 5 to the power of 2 is 25. Correct, very good. So this is correct. Minus 5 to the power of 2, also correct leh. But then it contradicts the certain this law, right? We say that the base must always be greater than 0. So if your unknown is the base x here, right? Okay, your x cannot be negative. Although you find that can, why you say cannot? Cannot lah, cannot. Okay. Next time when you go higher level, you will understand why cannot, and you will know why when we define all your index laws, we define a, the base, as positive, okay? And because this logarithm is linked to indices, so the a here must be positive as well, okay? You will understand better when we do the graph, okay? I will skip the explanation for now. You just need to know that by definition, the a, right, the base must be positive, okay? So in this case, because x is the base, right? So it must be positive. So you have to not mark wrong. You have to reject. Okay? You automatically on your own must reject. Okay? The examiner won't ask you in the question, will you reject one of the answers? They won't ask you. You automatically must know that you have to reject. Okay? Now let's go to the next one. Next one is like that. Solve this. Alright? Again, the way to solve it is to change it. That's why I said it is so important. You need to know how to change from here, like that. Okay? So, how do we do it? We take 2 to the power of p equals to square root 8. Alright? Now, are we able to change both to the same base? We are. Okay, remember, this square root means root 2, right? This is power 1, right? So it's 8 to the power of half. Okay? Now you just consider 8 alone. You change 8 to 2 to the power of 3. 3 times half is 3 over 2 lah. Then you can write p equal 3 over 2. Finish already. Okay, so that's how you solve this particular question. Now let's look at one more. One more. Hence, hence means this word hence, you will see it very often in mathematics, okay? Meaning you have to use this result, okay, to solve this. So let's see anything that's similar. Oh yes, we see that this is exactly the same as this. And this is p, and p is 3 over 2. That means this is 3 over 2. Alright, the rest remains the same. Okay, now we move from here to here. We continue from here, okay? Now, how do I continue? You see, it's the same old story. Wait, let me cover it. Same old story. What same old story am I talking about? It's this same old story lah. You know, maths are very boring one, you see? The same old story. It's always the same old thing that you use. Okay, so change this to index form, which is base 9 to the power of 3 over 2. And then you get this. If you don't know what is 9 to the power of 3 over 2, you press calculator, okay? It's actually just square root of 9 to the power of 3, which will give you 27. Alright? Then, you see, you can take, you can minus 31 on both sides, right? Because you're trying to make x the subject. Okay? So, you isolate this. 27 minus 31 is minus 4. After this, same old story. change to index form. So x to the power of minus 4 is 16. And then what do you do now? You can, if you can't see, then you do like what I do. You change this to positive power. Alright? Then you do this. And then you fourth root both sides. Then you get this. Alright? Again, you ask me, hey, fourth root both sides, isn't it plus or minus of this? Remember, when you have an even power, then you go and fourth root it or square root it or whatever, right? There'll be two answers. So you need to show that this is rejected. Okay? Why reject? Because this x is a base. And you cannot have negative base. So that's why you reject. So the answer is half. Alright? So that's all for this particular question. We'll now move on to another thing. Actually, it's not really another thing, but the same thing. We want to solve this, okay? So how do you think we should solve this? It's the same old story, change the logarithmic form to index form. So this is base, this is the index, this is the answer. The argument is the answer. So x to the power of 2, x to the power of 2 is equals to this, right? Oh, then it becomes our very familiar algebraic equation, which you can solve easily, and that's all. Alright? Now, please check that your answer fits in here. Okay? Without having, without any need for rejection, because a bit positive, okay, put in, okay, you go and check, both should be okay. Alright, so always make it a habit now. Okay, cultivate this habit during this holiday of checking whether your final answer fits into your original equation. It will help you a lot. Okay, now let's look at the next one. Wow, this one looks difficult, but no big deal no big deal. It only looks scary. Okay, life is like that. Things that look scary actually is very simple. Okay, again, this is your base. This is your index. But this index, you must put bracket, okay? Otherwise, you will make mistake, okay? 9 to the power of x minus x plus 1 is equal to square root of 27, like that. Make sense, Okay, now use your Emaths concept. Change them all to base 3. I told you already, this is 2, this is 1, right? So it's actually 27 to the power of half. And then this is 3 square. And then you see why I need to put the brackets. So that I know that I need to multiply 2 to this and this. Okay, many of you still make this mistake in your end of year. So please take note. Okay, after that, change this to base 3. And then you equate the power. Then you get this answer. That's all. Okay, you will notice that, oh, x is not a base, so it can be negative. Alright? Okay, now let's move on. Or, why is there or? You mean there's another way to solve this question? Is there another way to solve this question? You can pause the video and think about it. Okay, after you pause, right, I show you another way. This method that you see here, from this step to this step, right, is what we call the change of base method. It's called change of base. What is this change of base? Sometimes, right, you look at this, it is log of square root 27 to base 9, right? Sometimes we don't want to have the base as 9. Okay, why we don't have the base to be 9? Because it doesn't help us to solve the question. Okay, so we can change it to any base we want using this change of base law. Very good. It's a very convenient law. So how do we apply this law? Very simple. You just see. Now, currently, this first step, right, the base is 9, correct? I don't like 9. Why I don't like 9? Because on my calculator, I don't see log of base 9. I only see log base 10, right? So I want to change to log base 10, which is a short form LG lah, LG. Oh, life is good, you know, like the brand LG, very good one. So I change to LG log base 10, log base 10, okay? Then you see what is in the argument is in the numerator. What is in the base is in the denominator. Make sense or not? Make sense. What's on top, stay on top. What's below, stay below. Okay, then the base you change to whatever base you want. Okay, you can change to base 10, you can change to base 3, whatever. You can change to base 3, you know, it will help you to solve this question. But no lah, I just change to log base 10. You see, I change to log base 10. So it's log square root 27, right? Over log of what? 9. 9. Then you see, I press calculator, I press 3/4, very happy. So it's just 3/4, you see. Then my x, I can easily find it as minus 1/4. Finish already, lor. Okay? So those of you who are more hardworking one, can you try changing to log base 3? Since I already written, I show you, okay? So how, you know how to continue? Okay, I show you. This one is 3. Okay, you look at the denominator. 3 to the power of what is 9? Answer is 2, right? This one is still x plus 1. Correct? Okay. Then this one is a bit more tricky lah. But never mind, I show you. 3 27 to the power of half, right? Okay, but 27 to the power of half is actually like that. Log 3, then this one I change to base 3. 3 over 2, right? Correct? Oh, can't see. Okay, like that. Okay, so now I ask you 3. Okay, let's look at the numerator. Okay, numerator here. 3 to the power of what is 3 to the power of 3 over 2? So easy, right? I repeat. 3 to the power of what is 3 to the power of 3 over 2? The answer must be 3 over 2. Okay? So 3 over 2 divided by 2 is 3 over 4. Okay? It's the same. It's the same. So x equals to minus 1/4, same. So you must be flexible and know how to do different ways. Understand? But of course this is easier because you just press calculator. No examiner can say, why you do this? Why like that? You can change to any base you want. You see, you can change to any. But you see, you must be smart lah. Why I choose base 3? Because I know that 27 I can change to base 3. I know that 9 I can change to base 3. Then I can work it out like that. Okay, you don't go and blur go and change to base 15 or 22 or whatever. Then you are in trouble. Okay? Yeah, so I hope this helps you learn something. Okay, now example, this one finished already, right? Okay, now let me prove to you because how you not happy? Say why you anyhow change the base? Can like that? Yeah, can. I prove to you. Wow, like very late already. Okay, I tell you what, how we've only done one question. Actually, I give you 2 questions. We only done one question. Never mind because we are learning something, right? Something new. Okay, I just show you this then we call it a day. Okay, very late already. Okay, proof of change of base law. So I'm going to prove to you this change of base law. Change of base law is just now what we did lah. Some of you may ask me, what change of base? Yeah, change of base. Remember just now, from base 9, I changed to base 10. Remember? Then from base 9, I changed to base 3. Remember? Very simple one. This argument on top. What's on top? Stay on top. What's below the base? Stay below. Very easy to remember. Okay? But How come can do this? Why like that? Am I cheating you? Okay, I prove to you. I prove to you mathematically. Okay. So I show you. Let's say you are given this. In general, this can be log of 17 to base 3, log of 28 to base 2, or whatever. It doesn't matter. Okay. So let's say you are given this. All right. Do you agree that I can let this, which is this, be equals to y? Okay. Why do I want to do that? Because I remember the same old story. I'm very good at changing from this to this, this to this, this to this, this to this, right? And I want to change this to index form. So how to change this to index form? The answer is equals to the base to the power of y, right? So a to the power of y is b, right? Agree so far? Agree, okay. No, silence means consent, okay. So I assume you agree. Nobody asked anything. Now how to continue, how to prove the change of base, You see, from log I change to index form. Now can I change back to log? Yes, I can. How to change back to log? I take log on both sides, at least c can be any number I want. So it can be like just now that question, right? I change to base 10, then base 10 lah. I change to base 3, then the c is 3 lah. Okay, so this c, right, is any number in the world that I want. Okay, now I take log of b to base c here on the left, log of a to the power of y to base c on the right. So that's what I'll get here. See, the b, a to the power y, a to the power y. Everybody agree? Agree, Okay, now, remember just now we say that this power can come down. Did we do that, I think we did, right? Okay, never mind. I can't remember. Never mind. If cannot, I'll prove to you tomorrow, okay? This power here, right? Very funny one, this power here, of this this whole argument, right, can come down here one, Yeah, they're equivalent, okay? So that's what I'm going to do, to bring the power down to the front here. So it's just y times log of a to base c. Okay, the only difference between this line and this line is I bring the power down to the front. Okay, now this is just y times log of a to base c. Okay, so if I want to find what y is, because y is my this one, right? I'm trying to find out what this is. Okay, so I need to find y lor. So if I make y the subject, it'll be this divided by this, right? Okay, now what is y? Y is my original thing, what? So my log of b to base a, it's actually equals to this over, you see, it's actually equals to this over this. So you see, the b remains here, the a remains here, and the c is any base in the world that I want. Then I've proven to you that it's true already. Okay, wait, there. Okay, so you go and look at this proof, then you will agree that the change of base law works. Okay, now I think we better stop here. I think it's about 45 minutes or so already. I'll continue this same old lesson tomorrow. Okay, thank you.